Hello everybody, welcome back. So let's go ahead and solve this partial. Okay, before we get started, I just want to rewrite something so it's easier for us to solve. So I'll rewrite like partial s with respect to over s equal to c over 2 mu times partial x. Okay, so the reason why we write like this because c and 2 over and mu is something not related to x, so you can treat it as a constant in this case. And the golden rule is you pull all the constant out. Okay, so I'm ready to integrate. So let's go ahead and integrate both sides. C over 2 mu times integrate of partial x. Okay, so what will we get? You get ln of s equal to c over 2 mu times x plus ft. Okay, this is where it's interesting. If I'm a normal student, I will raise question immediately. I will say, "Oh, why isn't this ft? Why this is not c1?" Right? Like a constant. Like when we solve for a separation variable for for a differential equation, the basic term. Why is not c1? Why write ft? Why is a function of t? Okay, so this is the reason why. So I will make a note. So you have to be careful. Okay, so you have to be careful. Why? Because s is a function of space and time, or x and t. Okay, so what does it mean? It means that s can be a function of t as well. So in this case, a constant, which is something not related to x, instead of could be a number, it could be a function of t as well. So in order to generalize it, you write ft instead of c1. Okay, because in this case, that is the most generalized way, and it represents the correct. It render a correct representation for s. Okay, so let's go ahead and continue. So we can exponentiate both sides. So if you e both sides up, so e to level n of something, it's just that thing. And if you so you get s equal to e to power c over 2 mu x plus ft. Or if you expand it out, you get e to the power of c over 2 mu times x plus e times e to power ft. Okay, this is the temporary results we got right now. Okay, now we are almost done. We can use 7 to solve for f of t, because f of t is a constant. We don't know what's that. So let me see. All right, we are halfway there. Okay, let me put a smiley face for y'all. Okay, smiley face, smiley face. Okay. Now let's go ahead and continue. We can use 7 because we have used 6 already to get here. So we can use 7 to solve for ft. So from 7, you get partial s to x equal to c times s over 2 times mu. Okay. Let me see, from 7. Did I label 7? Okay, give me 1 second. I think I forgot to label 7 somewhere. Okay, I see. Okay, my bad, guys. So should put a 7 right here. So the 7 represent the partial s with respect to x. Okay, I see. So this is from 7. You can calculate the terms and then you can plug into 5. Okay, my correction. We use 5 and 6 to solve for the equation, the full term. So we use 7 to compute the term and then plug into 5. Okay, so let's go ahead and see what's this term. Partial square x to x square. So it's equal to the partial x with respect to x, this. Okay, the derivative, the second derivative is the derivative of the first derivative. Wonderful. So you can plug this in. You can plug this in. So S over 2 mu. Okay, so what does it equal to? C over 2 mu is a constant. You can plug it out. Time partial S, partial X. Just that, it's left. And partial S with partial X, it's just the term. You replace it one more time. That's the trick, y'all. I'll do something like this, I would say. It's also equal this. So C times S over 2 mu. And if you simplify it, it's C squared S over 4 mu squared. Okay? Wonderful, wonderful. Now, you have these two terms, okay? Let me write that. Yep, the partial S with respect to X. Okay, let me make it nicer. And you also have the second derivative with respect to space or X. You can plug it into 5. You outright plug these into 5. We have what? We have partial S with respect to time times 1 over S plus C times S times C over 2 times mu times S minus mu over S times C. Okay. C squared, yeah, over S 4 mu squared equal 0. Okay, so basically I use the equation 5 we have defined above, and I just plug it in, okay? Okay, so I'm gonna go ahead and simplify these terms. So partial S with respect to T times 1 over S plus C squared over 2 mu minus C squared over 4 mu equals 0. So I calculate, so partial S with respect to T equal times 1 over S equal to C squared over 4 mu minus C squared over 2 mu, which is negative C squared over 4 mu. Okay, now let's go ahead and solve for the time gradient. So partial S with respect to S times S both sides, we get partial S with respect to T equal to S times negative C squared over 4 mu. Okay, this is the interesting part. If you recall from above, from above, we have derived it already, I think. Pretty much so. We have what? We have derived S is e to the power C over 2 mu times X times e to the power f of t. Okay? And ft is the mystery element we need to find. So what is partial? Let's compute partial S with respect to t. What's that equal to? Is equal to e to the power of c over 2 mu times x. Remember, y'all, when you take your partial derivative, if this is in case of t, so everything related to x is a constant. So I treat the term highlighted blue as a constant. Okay, and what's the derivative of e to the power f of t? So it's just e to the power f of t times f prime of t. Right? So we can plug this in. So I'll do this, and I say e to the power c over 2 mu times x times e to the power f of t times f prime of t equal to s times negative c squared over 4 mu. Okay, what is S? So S is these terms. So I'm gonna substitute one more time. So e to the power c over 2 mu times x times e to the power ft times f prime of t equal to e to the power of c over 2 mu times x times e to the power ft times negative c squared over 4 mu. So what I did is I just replaced x with this term. Okay. So can we cancel out from both sides? Yes. So we have this term e to the power ft is the same. And we have e to the power c over 2 mu times x is also the same. And we have, what do we have left? We have f prime of t equal negative c squared over 4 mu. So you can solve easily for f of t. Okay. So what is your f of t? Your f of t is just negative c squared times t 4 mu plus c1. Okay, this is when you can write c1 because this is just an ordinary differential equation. Okay, so c1 is just a constant. It's nothing related to t, and f is just a function of t, so you can write c1 as a number, it's a constant. Okay, wonderful. In this case, you don't have to look for this family of solutions. Remember, s of x of t is something we can choose. So we can choose c1. So I would say pick c1 equals 0. So you have f of t equal negative c squared times t over 4 mu. All right. So we have f of t already. So we can complete the s. So remember our s is e to the power c over 2 mu times x times e to the power ft. We can substitute ft in. And let's see what we get, okay? So it will be e to the power c over 2 mu times x times e to the power of negative c squared times t over 4 mu. Okay, so it will be e to the power c over 2 mu times x minus c squared times t over 4 mu. So what is that equal to? So if I factor out c over 2 mu, inside it will be x minus c times t over 2 left. Okay, so what does it mean? It means that your u of x of t, yeah. So let me make a comment here. We found the supplementary equation, yay, or s x of t. Now we can substitute in x and u x of t. So what is u x of t now? If you solve this problem, if you present it to a conference, if you teaching your peers, or you discuss with your friends the homework, this is what you say. You say, y'all, we're gonna set u of xt equal to t of xt times s of xt, which is a supplementary equation. And after all this thing, I tell you, you say you can set g x of t times e to the power of c over 2 mu times x minus ct over 2. And by this substitution, by magic, it will lead our original partial differential equation to something that solvable, to a separable partial differential equation, which is I can partial t over t equal to mu times partial square of t over partial square of x. And by solving this, we obtain g. Okay, let me make some comment here to for y'all to see the thinking process. By solving this blue equation, we get g of xt. And after g of xt, we can get u of xt. Thank you everyone for observing my presentation for this method, and I'll see you in the next video. We will do a Black-Scholes equation with a very similar idea. I'll walk you through it. I hope you have a blessing day, and I wish you always happy and living a fulfilling life. Thank you so much.